Hey guys, welcome to another Kubernetes hands-on video. In this one, I'm going to talk about K8sGPT or Kubernetes GPT, which is a super cool open source project that helps you bring the power of AI and language models in particular into your Kubernetes projects and into your SRE workflows. It comes with a CLI. It helps you scan stuff, interact with your Kubernetes cluster, and if there are any issues, analyze those issues using AI backends. Also comes with an operator, embeds the analyzing logic of the CLI into the Kubernetes reconciliation loop. And what is super interesting is that the creator of the project has recently built a POC or proof of concept for an AI-based pod scheduler, which is super cool. Uses Kubernetes GPT server or pod running in the cluster as an AI backend, and the scheduler does the pod placement job using the power of AI. It is, as the creator suggests, that is pre-infancy phase. It's not something you can use in a production cluster, but it triggers the idea of building AI powered and control planes into the minds of the people who are into building control planes. I'm super excited. Let's get to it. All right, so let's start by looking at the GitHub repository of K8sGPT. Let's start by looking at the repositories. As I said, we're going to look at the CLI and the operator of K8sGPT, and then we're going to look at the POC of AI scheduling. Schednex has its own GitHub organization, I guess maybe because it's going to develop into a wide range of AI-based control plane tools, so it makes sense to separate it from a Kubernetes scanning and troubleshooting tool. To make things much easier, I'm going to work with this ClearCoda lab that I have created. This is the address of my ClearCoda lab environments. This one, bring LLMs to your SRE workflow, is the lab we're going to work with. So as it's talked about, K8sGPT is a tool designed to scan Kubernetes cluster and diagnose issues through LLMs. We're going to look at CLIs, the operator, and Schednex. So let's start. I have configured this lab environment in a way that the prerequisites are automatically installed when you start it. So if I now type in K8sGPT, I see that I have the command line here installed and the different options, the commands that are available to me. If you want to know how to install it, you can simply check out the GitHub page or the documentation of K8sGPT. It's super easy. First thing, we talked about AI backends. The most popular ones, the most dominant one is the ChatGPT. So if I type in this command, it will prompt me to create an API key. Probably you have an API key of ChatGPT. If not, you can just click on this link and create one. Recommend generating a new API key for this AI lab and immediately delete it after you're done with the lab. So if I click on it, I have, for example, these two keys here. You can also create your own. So if I now type in this command or simply click on this to execute it, it is asking me for the API key. So I'm going to pause the video, enter my own API key here and continue. All right. So I added the OpenAI API backend to my Kubernetes GPT. Now, if I type in K8sGPT auth list, I should be able to see that I have an active OpenAI AI backend configured for K8sGPT, and these are the options available to me. Let me zoom in a bit. Local AI, Amazon Bedrock, and so on and so forth. So we're going to continue. So let's intentionally create an issue in our Kubernetes cluster. If I simply click on this block, it will create a broken pod, which is using Nginx with a wrong tag. So if I click on this block, it creates a pod with an image tag that does not exist. So if I now look at my pods, I see I have already hit the image pool back off. If I want to analyze this issue, so let's say I don't know what is image pool back off. I want to analyze this issue using K8sGPT. I just run K8sGPT analyze. Up to this point, AI is not involved. It just looks at the status of the pod resource or events and so on and gives you the error message directly. So this is the raw error message that is set on the pod. And if you understand right by looking at this error, what is going on and what is wrong, you might be able to fix it. If not, you can ask AI to solve this problem for you, or at least give you some hints, because this CLI does not have the role-based access or the permissions to patch or edit resources or make some changes. It just gives you some hints how to fix the issue. So I did the analyze. I see the error message. I haven't tried to ask AI to explain this issue to me. So first thing, if there are more than one issue, which most probably in most of the clusters there are so many issues, so many errors, you can filter the issues to the resource type. So K8sGPT, as we looked at the help, comes with a bunch of commands, and one of them is filters. So we use auth to authenticate against our AI backend, and now we use filters to see what kind of resources we can filter for. So if I just type in this command, I see that I can, K8sGPT with its current configuration can give me tips or hints on how to solve issues if that issue is about one of these resources, PVC, services, stateful sets, so on and so forth. If we want to filter a specific issue to a certain resource type, when we do analysis, we can just say, okay, filter only for pod issues. So just simply gives me the error that is going on in regards to pods. And if I want to constantly add some filter and only focus on certain resource types, I can add to my filters and remove from my active filters. So these are the active ones. If I remove, for example, if I'm not interested in troubleshooting mutating webhook configuration, I can just remove it from my filters. Now, the interesting part, we want to get some explanation. Tell me why this is happening. By using this -- explain flag, K8sGPT CLI will give us some hints. So let's just do it. I can either run this command or this one. Doesn't matter, because currently I have only one AI backend. If I had more AI backends, I could choose which backend to use to explain the issue. So if I just click on this, it takes some time. It communicates with the OpenAI API and gives me a 4-step solution. What might be the issue for this problem? So now let's move on to the next part, the operator. All right, so we looked at the CLI. It is super cool, but the idea of Kubernetes or the Kubernetes API is to be able to define declarative APIs that can automate the stuff for us and use the Kubernetes reconciliation loop to automatically perform this operation and constantly look at the Kubernetes resources and our Kubernetes configuration and see if something is going wrong, and raise events or raise alerts or create results that can show these issues. The prerequisites for installing the Kubernetes GPT operator, we need Prometheus because we want to send Kubernetes GPT metrics to Prometheus. So let's start by installing Prometheus and give it some time. I will run this command to create monitoring namespace and install Prometheus Kubernetes stack Helm chart into it, and wait until everything is up and running. So it will take some moments. So I'm gonna pause the video shortly. All right, so the chart installation is done. So if I now look at everything in the monitoring namespace, I see I have a bunch of stuff running: Prometheus, Alert Manager, the pods, the services, and so on. I also have some services, as you can see. I would like to have access to the for example, the UI of Grafana or Alert Manager or Prometheus. That's why on ClearCoda, I can create node port services and simply access these links to have access to those services or to those web UIs. So let's just create the services. I have 3 additional node port services for Prometheus, Grafana, and Alert Manager. So if I now click on Prometheus, this is my Prometheus UI. You can type in your query, and you can also look at the endpoints there. Let's open up Grafana dashboard. Grafana needs some credentials, so the username is admin. I will type in the username, and the password is prom operator default credentials. So let's get in. All right, so far this is pretty standard, nothing extra, nothing K8sGPT related. So if I now go back, we need to install the metric server, which is something Kubernetes GPT uses to send the metrics to Prometheus. All right, so I'm going to install metric server, and then I'm going to patch it to add this kubelet insecure TLS, because this is a kubeadmin environment with self-signed certificates which do not have the right domain name. If I add this flag, I can simply patch the server to bring it to a running state, and it does not crash. So if I now look at everything in the kube system namespace, I see that my metric server is running, or at least will be in a running state soon. The older one should be deleted soon, and only one should stay running. All right, this looks good. Cool. Now I want to deploy the Kubernetes GPT operator. I'm going to add the Helm chart of the Kubernetes GPT operator here and simply install it. And let's look at the flags. It's going to create its own namespace. It's going to be installed in the K8sGPT operator namespace, and Grafana dashboard enabled, service monitor enabled, and Interplex is a currently being developed service. So I'm just going to simply run this. So I've already installed K9s on this environment to get stuff easily and navigate through the Kubernetes cluster easily. So I'm going to start K9s, and this is our broken pod in the default namespace. If I look at my namespaces in the kube system, I have the metric server running. And if I look at the K8sGPT operator system, I have the Interplex pod, which we're not going to get into in this session, and the K8sGPT operator up and running. Super cool. So let's exit out of this, create a secret for our Kubernetes GPT custom resource. So we installed the operator. It has already extended to Kubernetes API. It needs a secret to be able to talk to our AI backend. And the AI backend, as we see here, is OpenAI, and it is using the GPT 3.5 turbo model. So let's create this secret and run this command to create the Kubernetes custom resource. I'm going to create this secret. I'm going to pause the video, create the secret, and then we can create the custom resource together and look at what's happening on the K8sGPT side of things. All right, I created this secret. If I look at the secrets in the K8sGPT operator system namespace, I have my secret in here. Now I can simply click on this and create my K8sGPT sample. I'm going to open a new tab, and in that new tab, I'm going to run K9s. So if I now look at the K8sGPT operator, I see I have a K8sGPT sample or a K8sGPT server running. The pod is called K8sGPT sample, which is the name of my custom resource. But this is a K8sGPT server running in here. And this server does the job of the K8sGPT CLI 24/7. So if, for example, you want to create more K8sGPT instances, you can create more of this resource and use different AI backends, configure your custom resource specific to what it is supposed to diagnose and scan for. So if I now look at everything in the K8sGPT operator system namespace, I see I have the 3 pods, the services, and so on. All right, super cool. Now we have K8sGPT, which is now installed and has Grafana and Prometheus and all the stuff enabled. So if I now look at the Grafana dashboard, I see, and if I refresh this page, I see I have now a Kubernetes GPT dashboard. Super cool. And if I look at it, I see I have some metrics going on. What's interesting is the analysis results show me that I have 2 issues in my Kubernetes cluster. What are those 2 issues? Let's look at our K9s again. If I go to my Kubernetes GPT operator namespace again, and if I search for results, I see I have, for each issue, I have a result object, default broken pod. So in the default namespace, there is a pod called broken pod. This issue is of type pod. The backend is OpenAI. And if I open this up, I see what is the issue, what is the solution for it. And interestingly, this ongoing development feature of K8sGPT Interplex also has an issue. If I look at it, I see what is going on. The stateful set is using a service that does not exist. Interesting. So you see it automatically scans whatever is going on in my cluster and sends the issues to the Prometheus, and Grafana can also visualize it. So if I now try to, now I have K9s in both tabs, doesn't matter. Let's close one of them. So I'm trying to now create an issue and a new issue. So let's say k run nginx2 -- image nginx2. This is, as I said, another problematic pod because nginx2, this image does not exist, but let's do it. We created another pod, and we're gonna give K8sGPT operator some time to automatically realize that there's an issue and update our Grafana dashboard. So if I just keep refreshing, at some point the issue should come up. All right, now we see that we have 3 issues. 2 of them are of type pod and 1 is stateful set. Let's move on to the last part, which is Schednex. All right, so now let's look at Schednex, which is the POC I mentioned. As I said, it's a Kubernetes scheduler that uses insight from the K8sGPT pod or server running in your cluster. It uses K8sGPT API to get recommendations for the best node. So it does the pod placement for now, so pod scheduling based on the recommendation coming from the AI API. So let's start by running this command to install the Helm chart of Schednex. This one to install the Helm chart. So if I now look at the K9s environment, if I look at my namespaces and go to kube system, I see I have the Schednex scheduler up and running. If I look at the logs of it, it says starting Schednex is waiting to be used. How can I use it? Let's start, go to the second tab. Let's exit out of K9s here and simply do run this command. So before I run the command and look at the Schednex magic happening, I am going to look at the code. You can definitely check out the code and see how it actually does this scheduling. If you look at the packages, you see if you look at the prompt section, so far, as I said, it's just a POC, super simple. It sends such prompt to the K8sGPT server. Basically, you can just simply read it. As I said, it's just like based on natural language. Given the following node and analysis of issues in the cluster, I want you to tell me the best node for placement. So it's really interesting to see like how relatively complicated, if you turn your metrics into natural language and try to come up with a meaningful prompt, it can be used to do control plane operations like pod placement and so on. So this can definitely be extended to other use cases that need to happen inside a control plane, and also the pod placement logic. If you look at the placement coordinator, you see, for example, there's a function here that find node for pod, for example. Simple logic. You can just read through the code and try to understand it. So let's get back here. We installed the Schednex Helm chart and the scheduler is running. So now let's create a deployment, which the important part is that pod template of the deployment. You need to mention scheduler name Schednex. So we don't want to use the default Kubernetes one. We want to use the Schednex one. So let's just do this and watch kubectl get pod. I see the pods are pending. Now they're sent to the, and this is interesting. This is the logs of our Schednex and it's saying scheduling pod. The response coming from the AI was that like put it on control plane. There are no taints on this control plane node. Simple workloads can be scheduled on the control plane node. And now it's done with all the 3 pods, and these Nginx pods are scheduled using Schednex, which is super awesome. And now let's look at the logs of our K8sGPT sample. You see, this is what has been communicated to the K8sGPT server. You see the query, given the following nodes and analysis of the issues in the cluster, I want you to tell me blah, blah, blah. And these are the information that is needed for AI to make a decision and to see how to do the scheduling decision. You can definitely take it from here and develop other control plane logic using the decision coming from AI. All right, so we are done with this lab. Super cool project. I like it a lot. I'm really excited to see how, in what direction AI-based control planes would go. If you like the video, please give it a like and subscribe to the channel. Share this lab or this video with your friends. I will definitely put the link to this lab and the all the additional links to the K8sGPT GitHub projects and documentation and so on in the description. Thanks for spending time with this video and finishing the lab. See you next time.